Hello wonderful person, this is Anton, and in this video we're going to be talking about a new discovery coming from right here, our neighbor Jupiter. In this video we're going to discuss the potential very large collision that this planet experienced billions of years ago, early in the creation of the solar system. Let's talk about this and welcome to What the Math. So our story starts right here, around Jupiter. A few years ago, we launched the mission known as Juno that I'm trying to select right here. This is, by the way, using the free software directly from NASA known as Eyes on the Solar System. You can easily find this on NASA's websites. So this right here is the Juno mission. I've talked about the mission itself previously. It's probably most famous for using these solar panels really far away from the sun. And here we only get about 2% of the efficiency when it comes to solar panels compared to our own planet Earth. But anyway, so as this beautiful probe was orbiting around the most massive planet in the solar system, which is Jupiter, which is somewhere right there far away, it started to discover a few things that we couldn't really explain. Now there are a lot of really exciting discoveries that have already been very thoroughly analyzed by the mission. Like, for example, we already have a very clear picture of the aurora on Jupiter's surface, and you can kind of even discover them by using this free application. We also have analyzed the magnetosphere of Jupiter very accurately. You can also see what all of this looks like in Eyes on Solar System. We even have a very accurate representation of the radiation field around Jupiter, as you can see. And lastly, we also have a more detailed picture of the rings that are kind of barely visible because they're really small compared to the rings of Saturn. But the more exciting news coming about Jupiter is actually coming from the inside of the planet. Because by studying the inner core of Jupiter, we started to discover something a little bit unusual. The core of Jupiter that you see right here doesn't seem to be as solid and as structured as we assumed it to be. It seems to be more dilute and a lot more spread out across the entire volume, as if something disturbed it. Now, this wasn't really very clear to us. We couldn't really understand why this is so, and we're actually still not even sure. There are possibly a lot of other explanations, but in this video we're talking about one of such potential explanations that's probably also one of the more exciting ones. And you could probably already tell from the title that it's about a collision with a very large planetary object. Basically, a collision with another planet. And although generally scientists today believe that planetary collisions are actually super rare, they only happen like maybe once every few billion years, and a chance of having a large collision with Jupiter, according to some of the scientists, is like 1 in 1 trillion. It's super unlikely. Nevertheless, for this particular paper, the scientists estimate that within the first few million years of the existence of the solar system, because of the amount of various planetary objects in the solar system, and because of the sheer gravitational attraction of Jupiter, the chance for collision was not so low. It was about 40%, or basically 40% chance that Jupiter did collide with something. And this is how the scientists behind this paper from Nature magazine try to describe and explain what we're seeing inside the core of Jupiter and why they think it's so diluted and so unusual. They believe that some sort of an object, a very large object, collided with Jupiter pretty much head on and changed the core composition and also core structure itself, eventually turning the core into this very large, very diluted structure that we have today, that even after 4.5 billion years still hasn't really solidified into a solid structure. In other words, this collision was so dramatic and so huge in proportions that it completely restructured the inside of Jupiter. But this wasn't a simple collision similar to the one that Earth experienced when the moon was created. Here, if for example we take an object, like let's just say something equivalent to Uranus in size, and then try to launch it at Jupiter, but here under an angle, you'll notice that as it collides with Jupiter, which is kind of what most of collisions we think are like, it would most likely only affect the outer regions of Jupiter. It would never really make it to the core, and all of the material that's going to be generated here is very likely just going to disturb the outer surface. Let's see what actually happens. I'm kind of curious what will happen in a few hours here. But it's not going to affect the core. So we think that this is not the type of a collision that happened here. This collision would not really change the core almost at all. On the other hand, a collision with a planet that's a little bit more similar to Earth or a super Earth, so anywhere from, let's just say, half a mass of Earth to about maybe 4 or 5 masses of Earth, would not really provide enough effect to affect Jupiter as well. It would most likely, let's see what actually happens again, it would most likely not really pierce through the thick layer of Jupiter, and thus would not really affect the core as much either. So here, after all of this explosion settles, it would probably leave something on the surface here and would maybe go through a couple of thousand kilometers of the atmospheric layer, but it very unlikely would pierce through the atmosphere or ever get to the core at all. And so once again, we believe that a collision with a smaller object would only affect the upper atmosphere of Jupiter, not so much the core. So a very unique type of a collision with a very specific angle and basically a very specific mass would have to have occurred to generate the effects that we observe inside the Jupiter's core. And what do these scientists think happened? And according to them, as Jupiter was orbiting the solar system, and here you can see it flying through the solar system, it received a head-on collision from a planet that was roughly around 10 masses of Earth in mass. So maybe a little bit less massive than Neptune and Uranus, a lot more massive than Earth, and also very similar to objects that we usually refer to as sub-Neptunes. So here, if we try to simulate this collision is going to happen head-on at a very, very high velocity. We believe that there were many such planets in the early solar system. We also believe that these planets were very likely responsible for colliding and possibly even producing some other planets like Earth and Mars. But most importantly, today we believe that one such planet still exists, and this is something I'm going to talk about in a few seconds after we see what happened to Jupiter when it experienced this collision. So this would very, very likely reshape the core of Jupiter, making it more diluted, but also because it's a head-on collision with such a massive object, it would also cause Jupiter to migrate. It would very likely change the orbital speed of Jupiter, decreasing it, thus making Jupiter move to a different location in its orbit. Now, planetary migration is something we believe happened many billions of years ago, but this could have been the start of that migration. If something suddenly shifted Jupiter in its orbit, it would then start shifting all other planets, including, for example, Mars and Earth and of course Saturn. So all of this could have started with this really massive collision that then influenced Jupiter's insides, and this is what we're observing. Now this is still a hypothesis, it's not a theory, and it definitely needs a follow-up study and a lot of other observation and possibly even more proof, but for now it does make a lot of sense. There is, however, another really important idea that all of this proposes. The idea is of having such a very massive planet in the existence of an early solar system, which of course gives more credence to the theory of Planet 9, because it is very likely that some of these planets did collide with Jupiter, but some of them, possibly even from the same planetary body formation region as the one that collided with Jupiter, may have approached Jupiter too close, and as a result of this, as a result of a gravitational interaction, got kicked out of this inner solar system and ended up moving all the way to the back of the solar system, where it then stabilized and is there today. In other words, this sort of provides a little bit more proof to the existence of Planet 9 and how it could have ended up in the far regions of the solar system. Now, for now, we don't really know if Planet 9 is real, we also don't really know if Jupiter received the collision, but both ideas do kind of come really nicely together, especially if we do discover that Jupiter received the collision, or if we discover Planet 9 somewhere out there. For now though, we don't really yet know if any of this is a fact, we just know that it's very possible, and this is the brilliance of science. We need to test and double test, and people need to try to disprove the theory before it becomes a fact. Until that happens, that's all I wanted to mention in this video. Hopefully you enjoyed it and learned something about Jupiter from this video. And if you've enjoyed this, don't forget to subscribe, share this with someone who loves learning about space and sciences, and come back tomorrow to learn something you may have not known before. Also, maybe consider supporting this channel on Patreon because it does help me quite a lot. I'll see you tomorrow, space out, and as always, bye bye.